Hey guys, welcome to Robotronics TYT. Today we're going to be doing a really cool and beginner-friendly project that uses an ultrasonic sensor. The aim of the project is to make like a car reverse sensor system. In this case, we have a blue and orange LED that detect how far an object is from the sensor. So if the object is more than 30 centimeters away, the blue LED will start blinking. The further the object is, the slower it will blink. And if the object is in less than 30 centimeters, then the blue LED will turn off and the orange LED will start blinking. And if the object gets closer and closer, then the LED will blink faster and faster. So let's get to it. So we're gonna need LEDs, some resistors, anything between 60 and 300 ohms, a breadboard, an Arduino UNO, an ultrasonic sensor of course, some jump wires, and finally a 3D printed mount. That's optional, you're not gonna need it. Okay guys, so here's the ultrasonic sensor. We're using a HC SR4 and it basically has 4 pins. Now I'll just quickly explain how these things work. We have a wall here and transmitter and a receiver. So what happens is that the transmitter sends an ultrasonic wave signal which touches the object and then bounces back, and then the receiver receives that signal, hence the name, and it works out what the distance is between the transmitter all the way to the receiver. So the distance for this green line that you can see right here is speed times time divided by 2, because we don't want the red distance, we want the green one. And the speed is the speed of sound, which is 343 meters per second.
Alright, so now we're into the simulation part. Now this is not compulsory, but I always do it for good measure. So in here I'm just outlining how the components are going to be connected to the circuit. This is just so you can use the simulation model in your real life application, since it's really hard to record where the cables go inside the breadboard. Sometimes you can't really see which cable went to what hole, so that's all part of the reason as to why I'm doing this. I am also going to attach a screenshot of the simulation so you can use it as a reference for when you're connecting all the components in your board.
Okay guys, so now the fun begins. All I'm doing here is exactly the same that I just did in the previous simulation. So as you can see, all the cables and components will be allocated in the exact same spot as they were allocated in the simulation. I even made it so the wires are the same color as the ones in the simulation to avoid every possible ounce of confusement. Don't worry too much if you can't follow through with this. This is not for you to follow through. This is more so you can see how the circuit looks like in real life, and maybe you can compare it with your circuit. If you have any trouble, just please look at the screenshot that I had uploaded. And don't forget that the anode from the LED goes right next to the resistor. So the anode is the longer leg of the LED. Now I'm just going to plug in the wires to the Arduino pins. They're exactly the same as the ones in simulation. And this is what your circuit should look like so far without the ultrasonic sensor. Now we're going to do the ultrasonic pins. This is really easy. So first of all, the black wire goes onto the ground, then the green one goes on echo, then we have the blue one on trig, and finally the red one on VCC. Really simple, we're just going to connect the cables to the Arduino. So the black cable goes on ground and the red one goes on 5 volts, just above each other. And then the green goes on pin 10 and blue goes on pin 11. And this is what it should look like, your whole circuit basically. I now decide to 3D print the mount for the ultrasonic sensor. I will provide the file in the description. And this is what it looks like. Coding time. Okay, so we're going to start by outlining all of the pins and values at the start. So just make sure you copy and paste, and as always I will provide the whole code in the description below. Okay, so now in this part we start triggering the ultrasonic sensor. We make sure that it registers all the distance
between the object and the sensor, and this is very important. This is how we map and calculate the distance. So these few lines of code show you how to do that. I'm not gonna go explicitly into detail, but if you read it, you'll figure it out by yourselves. And this final part, we're activating the LEDs. So make sure that they blink faster and faster as the object is closer and closer. So basically that's all the code, guys. It's quite simple, honestly. Cool. So now I'm going to attach the 3D printed now into the ultrasonic sensor. There we go. And we're going to connect the Arduino cable to the Arduino UNO. And finally, we're going to click on run the code. And now the code is running and it's working, as you can see. The blue LED is blinking. And if I move the box a little closer, we can see the orange LED starts blinking when it reaches 30 centimeters. The closer I bring it, the faster the LED blinks, which is exactly what we were looking for. And now it's blinking really fast because it's really close. If I put it away, it's going to slow down. Once it's past 30 centimeters, now the blue LED will start blinking slower and slower as it goes further and further.
And that's all, guys. Thank you so much for watching. I hope you enjoyed the video. If you did like it, please subscribe, and I'll see you next time.